Good morning and welcome to the beginning of day 2 of ESMARConf. I'm really excited to be here. My name is Martin Westgate. I'm part of the organising committee for the conference and one of the co-founders of the Evidence Synthesis Hackathon. Some of you may have been online already for our first workshop of the day, but this is the first set of talks. It's a shorter session to begin with. We've got some more stuff coming up later on, but you're here for session 4A on reporting, I hope. So we've got 2 talks. We've got one from Neal Haddaway and one from Charles Gray. I think it's going to be an interesting set of talks, and we've got time for discussion at the end. So yeah, without too much ado, I'm going to hand straight over to Neal. Hope you enjoy your time.
I'm going to introduce to you today the Prisma 2020 R package for producing flow diagrams that have the possibility to be interactive. So why are flow diagrams important for evidence syntheses? Well, they often deal with very complex sets of data, lots of methodological stages, many different numbers from different places, and lots of different records, sometimes tens of thousands or more. And it's important to be able to keep track of all of those records. Flow diagrams do that very nicely. In the case of Prisma, this is the Prisma 2020 preprint version of the flow diagram. And I'm going to describe the process of how the Prisma 2020 R package and Shiny packages, Shiny apps work. So the main function is Prisma flow diagram, and it's based on GraphViz and uses diagram R. In this code, in this language, I use the term nodes for boxes and edges for arrows, and the package automatically connects the boxes with arrows. But for this case in Prisma 2020, I use explicit node location. So I explicitly say where the boxes should go. And another important factor is that the previous and other arms of the Prisma 2020 flow diagram are optional. So if you haven't integrated studies from previous reviews, or if you haven't searched other sources of information, those arms can be dropped from the resultant flow diagram. It also has what's called responsive location of the exclusion reasons node. So the box that has exclusion reasons in, where each line is a different exclusion reason, can be varying sizes depending on the number of exclusion reasons. And Prisma flow diagram, the function responsively moves the boxes around depending on how big that box is to a certain degree. So this is the flow diagram again, and on the left you can see the optional previous studies arm, and on the right the optional other studies arm. So within the R package, data can be read in from a template CSV file. Here's a screenshot of the CSV file, and the data that can be changed by the user and that is read as different is in this red box. So the other columns are there for the user to understand which box the information relates to. There's also a template schematic that shows for the box column which box is which to make it easier. But users can change the box text. They can change the tooltips, which are the text that appears when the mouse hovers over a tool when the interactive version is used. And the URL is the link that is used when the user clicks on an HTML version if the user specifies interactivity. And then the final column, in this case N, which was K in the original Prisma 2020 flow diagram, is the number of studies or number of records at any step. You'll notice for 2 of the boxes there are multiple reasons. So where there are multiple reasons, each reason is separated from its number by a comma and from the next number by a semicolon. And the template shows you how to do that. It won't function if you don't enter the data in that format. So some of the challenges with this are that the vertical aligned text in these blue boxes is incompatible with GraphViz. So what we needed to do was to append that into the HTML using JavaScript, using the package's HTML tools and HTML widgets, and it adds text that is rotated through 90 degrees. And this is the function. I won't go into detail, but there's JavaScript in there. It embeds that JavaScript into the HTML after it's been produced. I also mentioned interactivity. There's a function srFlowInteractive, and it turns a static Prisma flow diagram into an interactive one. Why is interactivity important? Well, it helps to support full transparency in that it allows you to see the fate of each record. Normal flow diagrams show the number of total records going through each step, but they don't show the fate of every single record. And full transparency allows you to see what happens to each record by examining a list of records at each step. It also facilitates data reuse and digital transparency. And it makes particularly online communication very simple by explaining methods in as much detail as the user wants to see. So the user can click on a box and either see the methods or the data, depending on what you want them to see. And the interactivity, again, uses JavaScript by appending href links into node elements. And those links, as I said before, are specified in the data entry. And tool tips are provided so that when the mouse goes over, a bit more information pops up. So there's two levels of interactivity: information provided in the tooltips and then information provided in whichever source you link to. There's also a Shiny app, as I mentioned. The beta testing version is up, but it's likely to change over time. You can see that on the left, you can specify which ARM is included, and down below you can enter the text as well for the values of n. At the moment, this is all you can change. You can just change the n numbers in the Shiny version. So some future developments are to add in the side panels. You'll notice there that the blue side panels aren't working because Shiny doesn't support JavaScript. I also want to build interactivity in so that you can click on the nodes and be sent to URLs. We're also trying to build in flexible data entry so that in Shiny you can either upload a CSV from the template or you can have manual data entry. And to integrate the flow diagram with review management tools so that this data automatically is populated from whichever review management tool you use. Thanks very much.
Okay, that was wonderful. Thanks, Neal. I actually got caught up literally trying to tweet about how awesome that software was, which is why there's a lag there. Apologies from my end, that's rather unprofessional. And in any case, we should hand over to Charles, because the next talk is by Charles Gray. She's going to be talking about reporting in network meta-analysis context. So I'm really excited to hear that. Charles, over to you.
Hi there, this is Charles, and this is my co-developer, Beanie, and we're going to talk to you today about reporting for network meta-analysis. Now, this is the end of my very first week as a postdoc with Gavin Stewart's Evidence Synthesis Lab, coming to you remote from the very hot Australian bush. And so yesterday we learned about network meta-analysis in the excellent sessions. We learned that network meta-analysis is a tool that we can use to ask which treatment out of a set of treatments works best, as opposed to standard meta-analysis, which asks whether a treatment works. And as we saw, a lot of these tools are in development, and we're just setting my timer, I realize. We're still developing tools and creating ways to report these things. And for me, I'm working on a Cochrane study, and the Cochrane handbook has some, has quite a substantial protocol to follow for reporting a network meta-analysis. And to find a guide to how to do this is not entirely clear. There are a whole bunch of different tools that I'm investigating, each of which do different things. And so to this end, I'm proposing not a definitive protocol, but a computational waystation, a stopping point between an individual's analysis and a formalized protocol that everyone will follow. somewhere where open scientists can come together, collaborate, comment, make suggestions, and participate in discussion. There are gaps in toolchain. There's no one software tool that will give me everything I need for the Cochrane reporting protocols. For example, multi-NMA, which is where I've started, which David Filippo gave us an excellent presentation on yesterday, has really great tools for Bayesian network meta-analysis reporting, but Cochrane requires contribution matrix, which we also heard a different talk on yesterday. And so to this end, I'm interested in building vignettes in R that will help myself and others produce reporting protocols that chain together various tools to produce, say, for example, a network meta-analysis reporting set according to Cochrane or Campbell. Matt Granger may well, I hope, provide some insight into how we can report network meta-analyses in an ecological setting. And
Charles, sorry to
we may want
interrupt.
to
we can't see your screen.
Oh, really? That's no good. All right.
Perfect.
All right, sorry about that. So we have gaps in the toolchain, and here's our contribution matrix, but we heard all about that yesterday. So I'm up to extending the toolchain. Now, here's an example of how we might extend on the toolchain. So if we go to our, for example, sensitivity analysis in a network meta-analysis asks, how much do the studies agree? And if you go to your Borenstein or the Cochrane handbook, it'll suggest doing a leave one out sensitivity analysis where you run the network meta-analysis again, but randomly select a study to omit. But of course, this begs the question, what if we were to omit a different study? Would we get a different result? What if we were to omit 2 studies? So here I constructed a little tool chain of the network from the example data set that I showed in the first slide, which came from David Filippo's multi-NMA package, and it has 5 treatments and 7 studies. And I considered, well, if I take every possible subset of size 3 or greater from those 7 studies, run a network meta-analysis, what ranking do I get? And here I produced a summary visualization of those ranking results. And you can see that the rankings do disagree for different things. I think that this is a little bit more robust than a single leave one out meta-analysis. However, this has drawbacks. This is running on all subsets of size 3 or greater for 7 studies. And this ended up at 99 network meta-analyses, which took several minutes to run on my computer. So this will become computationally intractable as soon as we go to a large number of studies in a meta-analysis. However, this toolchain may be useful for someone performing a network meta-analysis on a small number of studies. So it seems like it may be useful to share that toolchain with the community. The next step for myself is to learn threshold analysis, which David Filippo also has another package for that, NMA Thresh. And however, this is significantly more challenging. So to put together this analysis here, it took me about an afternoon, whereas I'm still learning how to implement NMA Thresh. So this toolchain may be useful for someone who doesn't have the time to invest and has a small number of studies. And thus, I think a computational waystation may be of use to the community. Furthermore, I'm interested in how we can democratize the contribution for these kinds of projects. So not everybody wants to engage with GitHub. If I take my research project, we have a psychologist who's leading it. She probably doesn't want to have anything to do with GitHub, but I can share the website and provide an email address where she can make suggestions about how to make the visualizations more interpretable. The lead statistician, Gav, who's supervising me, may well have comments, but may not have time to contribute code. So he can engage via the discussion forum. And that's public, so others can read his comments and also comment themselves. And of course, there's me, the intrepid postdoc, maintaining it. Now, for the computational collaborators, say, for example, if I asked Matt Granger to contribute an ecological protocol vignette, for reporting network meta-analysis, there's a really excellent workflow provided by the Use This package. And there I've got a link to the pull request workflow with a very small set of functions to do precisely the single thing of contributing a small thing to another person's package. This significantly reduces some of the challenges with GitHub, and I think it's well worth experimenting with, and I warmly encourage the community to try and practice and learn this with me. This talk is fully reproducible. You can access the source code, and I've written up a little manuscript about computational waystations with network meta-analysis reporting, which is also reproducible and available via this link. So thank you very much for listening, and thank you for introducing me, Martin.
That was wonderful, Charles. Thanks so much for that. It's really great to see. And also, Neal, for your talk as well. I was blown away by that. I hadn't kept up on your respective software projects over the last months, and I clearly should have. So we still have some time. We've got plenty of discussion time now. I'm trying to keep an eye on Slack and Twitter, but only with limited success, as I think I demonstrated earlier on. So in the meantime, I might jump in with the question, which is that, look, both of you guys are reporting some pretty advanced and pretty complex things, and you're trying to use this new tool, these new tools, to do that in as clear a way as possible. And my experience of that has sometimes been that you hit challenges. Particularly, Neal, you mentioned the benefits of interactivity, but the options for hosting that stuff as part of a journal article are quite slim at the moment. So how do you feel these things are going? As people are pushing the limits of trying to publish technically complete academic research, do you think that publication will catch up? Do you think we need to amend our methods or approaches? What are your feelings?
Yeah, if I could jump in quickly, I'll put a plug it here for a talk later on today in the Open Synthesis session by Matteo Mancini on reproducible meta-analyses that he's published in eLife. And they are published as reproducible, replicable HTMLs that I think have RMD in the background. I'm looking forward to his talk. So they're not PDF based, they're not static. And the Prisma flow diagram, so people can use it in two ways. They can produce a static version that goes in a PDF, or they can produce an HTML version that's then interactive, as I said, with the mouse over tooltips or the hyperlinks. I think there's going to be a move towards more interactive, Web 2.0, Web 3.0 ways of communicating science. I think the days of the PDF are on the way out. I think PDFs will go extinct as a means of communicating science because of this lack of interactivity. And one of the key principles in science communication, I think you'd agree, Charles, is simplicity, and that the more detailed you get in your analyses and the more you try to be open, the more information you produce, and it can be overwhelming. And by having that information in a hierarchical, overlapping design like you can in a website. So if you're a methodologist and you go to a systematic review and you want to know what someone's done, all you need to do is have a look at the flow diagram to start off with, and then you can click on each box to get more information about the methods behind and their results. So that level of interactivity, I think, is really important for giving the user control over what they see and how much, with design in the background of a framework of, this is the first bits of information that can help you decide which you want to see. But I think that level of support and handing the reins over to how much the user sees can be really important when we're talking about open science and that volume of information. And I think that's the same, right, Charles, when you get to reporting the level of detail you're talking about.
Yeah, I agree very much. I think there's a few things going on in the sense that I couldn't agree more that we're moving away from a PDF as the research artifact that we're aiming for, and more towards interactive living resources. But in terms of our work as researchers, I think there's a scaffolding that needs to happen that we're still very much figuring out. How do I engage with other computational scientists is very different to how I might, say, engage with people at Cochrane who are interested in just the output and not in developing new tools. And I think that really goes to what you were talking about in your workshop this morning, Martin, with modularization. And I think modularization is, we're shifting into that kind of landscape where Metaphor and MetaGear are, you know, fabulous packages that have some really interesting and useful tools. I use them all the time, but that I think we're shifting in a research software engineering sense from large all-encompassing packages that do everything to small little modularized components that we can work on together as researchers. So for example, Shinichi's recently developed an orchard plot package. And that's just doing the one plotting tool and not doing everything with network meta-analysis.
And so, Charles, it sounds like from your talk that trying to engage effectively and using the appropriate mechanism for each audience has been a real focus of yours. But even the sort of language we're talking about here, where we talk about code at all, is profoundly off-putting to some people. Have you found it challenging? Extremely
challenging. And you know, for myself as well, there are aspects of code that I find easy, but then, for example, Git, I think is one of the biggest challenges that I constantly struggle with, that some of the, you know, more experienced and trained computer scientists I know seem to just, you know, work with very easily. And so I think we're still figuring out how to best engage with people. It ended up becoming more the focus of my doctorate than the actual meta-analysis estimator itself. Was how do we structure these kinds of analyses, and how do we reformulate what a research artifact is and what purpose it serves?
Yeah, it's an interesting exercise in that. So I've recently gone from being in a university to working in what I guess you could say a tech firm, though it is, you know, within a public service space, and trying to work out how you can support users that may go from people who have no idea what you were until they literally clicked on your website through to people who are, you know, maybe experts in a specific domain, computer science, ecology, whatever. And that's orthogonal against their coding knowledge, perhaps. So it may be that some have expert scientific knowledge and not coding knowledge, or the other way around. Yeah, working out how to communicate across those kinds of audiences is a huge challenge. And I think the approaches you've demonstrated today are an attempt to sort of move across those boundaries.
Yes, very much. Although I think it's just you know, just a beginning, really. You know, what I was thinking about in particular when I put those steps together was my experience as a tidyverse developer contributing to Broom for meta-analysis. So Broom is a package that produces standardized model output for all models. And I worked with Malcolm Barrett on, or he did most of the work, and I spent most of my time confused by Git, but and on S3 methods. But they have a really detailed protocol about doing a pull request, but that was extremely challenging for me. And I'm really meant to be specializing in, you know, research software engineering. So I think that kind of engagement is great for someone like me who wants to skill up in it, but it's not the way to engage, say, my principal investigator who's a psychologist and not at all interested in coding. And so I'm really interested in, you know, these are just my nascent thoughts on this, and I'm very interested in the community's thoughts about how we can engage with different levels of computationally engaged stakeholders.
Yeah, fair enough. So we've actually had a targeted question from one of our people on Slack. So thanks, Suzanne Freeman, for watching along and asking some questions. So this one's for you, Neal. How far along are you with allowing users to input their own data from CSV files? And what issues do you foresee with implementing this?
Yeah, so actually that was the first format of the Shiny app. So some of the people who've been beta testing the earlier stage of the Prisoner flow diagram Shiny app had a template CSV that they could change the tooltips, the URLs, the box text, and the numbers, and then upload. And that was a little bit ugly and had a few problems with different versions of the template. So we moved to the data input, which was one of Luke's suggestions. So I need to acknowledge Luke McGuinness and Matt Page for their support and help and contributions, which I forgot to put in my talk, I'm afraid. But that was an earlier stage. But what we want to do, so in the R package, you import your data that way, or you can input your data manually as objects. But what we want to do, starting from next week, I'm working with a group with living systematic reviews. And with living systematic reviews, you have multiple flow diagrams, one potentially for each update, and then you could have it cumulatively. You could have it in lots of different designs. So that data is much more complex and would need to be uploaded in a much more complex spreadsheet. We also had discussions around how much we should allow users to change text, because you could change the text to the point where the flow diagram is inconsistent or doesn't actually support the Prisma 2020 checklist. So there are some issues there that need to be resolved. But the first version of this package was literally just to replace people having to design it themselves. So we're iteratively building on that. Also, I should say that there's one for roses. So Prisma is a set of reporting standards that's been around for systematic reviews and meta-analyses since 2009, I think, largely used in the field of healthcare, social welfare, very widely used. ROSES is reporting standards for systematic reviews and systematic maps in environmental science and conservation. So it's specifically designed for systematic reviews and systematic maps. And there's 2 flow diagrams for each. So there is an equivalent interactive flow diagram Shiny app and R package for ROSES as well that works in a similar way. One of the questions actually I have for you, Martin, and you, Charles, if you're working on a Shiny app and an R package, because I'm not on, the package isn't on CRAN yet, I have been pushing some of the functions over to a script alongside my Shiny app that I then pull in using source, which was one of Luke's suggestions. And then I have 2 versions of every function that I have to update. I'm sure there's a better way of doing it than that. But if you're working with Shiny apps, you obviously need to be quite careful that you have the code in the right place and you're being efficient. Yeah, not a question so much as no.
It's just, Shiny apps just so hard. Like, I recently found out that there's a thing called modules for Shiny apps that have been around for like a long time and I've never heard of, and they're specifically designed for complex Shiny apps. And I write that a lot, and it's amazing what you learn. I mean, and actually, I also learned that you can put an R folder in a Shiny app just like you can in a package, and it will draw in functions without you having to use source. So I don't know if that's the solution to your problem or not, but it's funny how every time I check the documentation, I think, oh, I'm really on top of this. I just need to check a detail. It's like, oh, I've misunderstood everything about how this software works. It's amazing any of it works at all.
Yeah, my suspicion it would be, every time I've had problems like that where I'm duplicating the code, it comes down to really getting my head around all the little minutiae of the reactivity of the variables, but it's a time sink.
So
there's us just not answering your questions, Neal. Lucky.
I wasn't being stupid and doing it really.
Commiserating.
Shiny, just look, I love it. I think it's pretty, but it's so hard. I spent like a whole day trying to fix CSS on a Shiny app and failed, like to literally change one thing. So clearly we're good examples of the coding community.
I have quite a lot of interest in trying to do things outside of Shiny in HTML. I'm an HTML coder by background. And so I think there are quite a lot of things that it's very easy to do in Shiny, but then you depend on an external server, and like you have to have an account and you have to manage how much people are using it, and you have to keep on top of resetting the server sometimes. And it's also quite slow to load. So I think if there's reactive things you can do in JavaScript and jQuery, I'm all for like going for those. In fact, the first version of this flow diagram app is interesting hearing you in the earlier workshop talk about earlier versions of packages, because the first version of this flow diagram was purely in HTML where you edited, it was HTML5, you edited the HTML in a web browser and then took a snapshot or saved a snapshot. was static. It wasn't interactive, and yeah, that was awful.
All of which just shows that optimizing software is a hard thing to do, right? And in your description of the data input needs, clearly that requires some sort of complex object, which is not what we're like. Trained is the wrong word, but we're not encouraged to think of storing things in complex objects because they're messy and unique. But sometimes that's the only way. And world's a complex place. Why should software not be? Anyway, I feel that's a rather pessimistic way to end. Does anyone else? Does anyone have anything they want to add before we finish?
No, I think that's great.
Lovely. Well, in that case, thanks everyone for tuning in. Thank you, Neal and Charles, for your time, and I hope everyone enjoys the rest.